In this section, we are going to talk about proportion. So, proportion is an equation that states the equality of two rates or two ratios. So, we're going to see a fraction equal to a fraction. And we're trying to figure out, usually, you're trying to figure out what one of the variables is going to be. One way to simplify a proportion is to think about finding that least common denominator. So if we were to find the least common denominator here, it would be BD. So I can multiply both sides by BD. And look at what happens when we do that. Let me see if I can change the color of my pen here. So you see how that B is going to cancel with that B, and that D cancels with that D. So you end up with AD is equal to BC. I like to think about solving proportions using the cross product method. And the cross product method says if A over B equals C over D, then I can multiply these together to get AD. And I can multiply these together, and those have to be the same thing. AD has to equal BC. So that's their cross product method. That only works when you have a fraction equal to a fraction, but it's a great way to solve proportions and proportion problems. And you see we get the same thing here as we did up here when we found that least common denominator. So let's look at an example. We have 8 over 5 equals n over 6. The problem wants us to solve for n. So I'm going to use that cross multiplying thing. So we have 8 times 6, which is 48, is equal to 5 times n, which is 5n. And that creates this little equation for us. The goal is to solve for n, so we're going to do the opposite and we're going to divide by 5. Right now that relationship is multiplied, so we're going to divide. And then if we take 48 and we divide it by 5, we're going to get 9.6. So n would be equal to 9.6. So what that's saying is that these are equivalent fractions. Right? The decimal for this would be equivalent to the decimal for this. And that's what that's saying. So if I take 8 and divide it by 5, I would get 1.6. And if I take 9.6 and divide it by 6, I'll also get 1.6. So you can see how those are going to be equal to the same. But the goal here is to solve for n. Proportions are really useful when we're solving different types of application problems. So let's look at an example. Fertilizer label shows that the ratio of nitrogen, phosphorus, and potassium compounds is in the order of 12 to 8 to 5. How many pounds of each compound are in a 100-pound bag of fertilizer? So let's figure out the parts here. So it's an 8 to 5, a 12 to 8 to 5 ratio. So the number of total parts would be 12 plus 8 plus 5, which is 25. So out of those 25 parts, we would expect 12 of them to be nitrogen, 8 to be phosphorus, and 5 to be potassium. So 12 out of 25, this would be for the nitrogen, has to be equal to something out of 100. So that's how we would set up to figure out what that nitrogen compound would be. So we have 25 times x is 25x, and 12 times 100 is 1200. And if we divide by 25, so 1200 divided by 25 is 48. So we would expect 48 pounds out of that 100 pounds to be nitrogen. Now let's deal with the phosphorus. So we had 8 parts out of the 25. That's phosphorus. And we're trying to figure out that equivalent percentage for that 100-pound bag. So again, 25x is equal to 8 times 100, which is 800. If I divide by 25, I get 32. So we would expect 32 pounds from that 100-pound bag to be phosphorus, and then no nitrogen. We had 5 out of the 25, that's nitrogen, and that's going to be equal to x out of 100. So 25x equals 500 divided by 25. So x is going to be 500 divided by 25, which is 20. So in that 100-pound bag, 48 pounds would be nitrogen, 32 would be phosphorus, and 20 would be, oh, sorry, this is potassium. Potassium right there. So that would be the makeup of the number of pounds for each of those components.